Thanks everyone for joining the session. Welcome to JNCIA training. Like CCNA and JNCIA, both are two different vendors, two different certifications. Like CCNA is a Cisco vendor, and Juniper is a JNCIA is a Juniper one. Now today we will start with Junos OS Fundamentals directly. Okay. So once you see right Juniper product, what are the hardware components in Juniper product common, and let's see the architecture. Okay, so today I'm going to explain about Junos OS fundamentals, operating system fundamentals. So what is a software architecture? What do you mean by control plane and data plane? What do you mean by routing engine and packet forward engine, transit traffic and exception traffic? Okay, so before that I'm going to teach you hardware components also. Let's see. So these are the Juniper MX routers, the famous routers. Everywhere in data center also they commonly used MX240 device. So I'm going to give a training on these three devices. Okay, MX240, 480, 960. Whoever is experienced candidates, right? After the completion of this training, you need to mention these models. I have a hands-on experience on MX devices. Whoever is fresher, right? You need to mention like I have a knowledge on knowledge. Freshers mentioned like that. I have a knowledge experience. Tell that I have a hands-on experience because I'm going to give you that kind of training to you to get a hands-on. Okay, very important devices. Okay, now EX4300. Mention this EX4300 in your resume because this EX4300 we have at our office. Go to office and look at this. This is a switch, L3 switch, EX4300. So these are the L3 switches, these are the routers in Juniper, and these are the QFX switches. QFX switches they're using in data center. So they design especially to carry a huge traffic in data center. Data center is handling with huge traffic, right? So specifically they design a devices. It's called QFX L3 switches. 100G, 400G, 800G bandwidth they can support. Okay, so these are the QFX switches we used in Oracle data center. We use these QFX switches 5100 series we used here. Okay, now firewalls, SRX firewalls. Each vendor will have a router, switch, and some firewall, right? So SRX firewalls, SRX 100, 200, 4100. There are a lot of models. These are the devices. Okay, yeah. Now let's understand hardware components of any Juniper device. Okay, experienced candidates, you know, if you know each and everything about Juniper product, you'll be having a very good opportunities. So since explaining about hardware components is not a part of Juniper training, but since I was a tech engineer, I want you to crack the interviews. So to crack the interviews, you should have a better understanding so that I'm going to give you this training. Okay. So that's why it's a industrial training. What exactly the industries are looking for, right? We are learning that here. So look at this. This device is called what? MX series 960 model. Okay. The difference between MX 960, 480, 240 is simple. Line cards all are same, but MX240, you will have a 4 slots. Look at this. One, 2, 3, 4. If MX480, you have 1, 2, 3, 4, 5, 6, 7, 8. How many slots? 8 slots. In these are MX240, 480, the slots are horizontally designed. Look at this horizontally designed. In MX960, how many slots we have? 14 slots. Okay. How they design? Vertically. Okay, so each and every model the line cards are increasing and the design of line cards are horizontal and vertical. Understood everyone? Hello.
Yes, sir.
Yeah,
Yes, yes,
yeah,
yes, sir.
yeah.
Yes,
Now
sir.
now go on mute. Now look, let's understand each and every component. Please go on mute. Karthik, please go on mute. Yeah, thank you. So let's understand now each and every component of Juniper. Okay, so first is SCBs. SCB, switch control board. Okay, switch control board. What does it mean? This switch control board you will install in here. Look at this. This is called switch control board. This switch control board you have two, 1+1. So switch control board, what it will do? It will be a slot where you can install a routing engine. Look at this, a routing engine here, a small. You see, right? This is a small box again. This is called what? Routing engine. Understand? So SCB you need to install on the chassis, and inside the SCB you have a routing engine. So routing engine is a heart of the Juniper operating system, because routing engine you will install what? Junos operating system. So whatever the operating system you use in Juniper, that is called what? Junos. So this Junos operating system you will install in routing engine. When you purchase any device, right? The routing engine will have a console cable. You connect a console cable to routing engine and log in the device and configure the protocols. So the routing engine, it installs Junos operating system and everything will run here. And exactly entire routing engine is installed in where? SCB. This SCB installed in chassis. So let me show you a video so that you can understand. You guys are with me? Hello?
Yes.
Yeah.
Yes, sir.
So if you see, right, I think you have already seen this video in Juniper hardware training.
Ready? One.
Not Juniper. I think
Yes, sir.
CCNA. Look at this. Whatever he is holding, this is called SCB, switch control board. Okay. So this is MX480 device. In MX480, the line cards. This is a line card. This line card is installing horizontally. What is the name of this line card? SCB, switch control board. Look at this. He's installing. See, the back end you have a pins. Back end you have a pins. Once you insert it, right, so the back end you have a mid plane. Motherboard will be there. So it will attach to the motherboard. Look at this. So they are installing like this. This is called what? Switch control board. And now inside the switch control board, you have a one more component. The component name is called what? A routing engine. Look at this routing engine. So the routing engine, what it will do? You will install Junos operating system in routing engine. This is Juniper operating system you will see. So if you want to install a operating system, you need a hard disk, right? Hard, see, look at this. This is a hard disk. This is a RAM. See how many RAM slots we have? Four RAM slots, and you have a processor here. So RAM, ROM, processor, enough, right, to install operating system. So this is called routing engine. The small part you see right here, he is holding. So this routing engine, where he is installing? He is installing in SCB. Look at this. He is installing where? SCB. It's a switch control board. So you see right here, you have two SCBs with two routing engines. You have to say 1+1 SCB, 1+1 routing engine. Why you have two? Because for redundancy. In case if in case the primary routing engine goes down, the line card, if it is failed, the data can, you know, the data can forward through another routing engine. Understand everyone? Call SCB, switch control board.
Yes, sir.
Okay, this is called what? Switch control board. See, look at this. So switch control board, what it will do? It houses a routing engine. What it will do? It houses a routing engine. Uh, this is a old PPT. Let me open a new PPT. Mm, 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 mm. Hmm. Where is the Juniper? Junos OS Fundamentals. Yeah, here it is. Yeah, you see, right? Right? This is the mid plane. Are you able to see, guys, now? The mid plane.
Yes, sir.
Okay. So this is the mid plane. Mid plane means what? Motherboard. Okay. So this is where you install SCBs, right? Yes or no? హలో ఇక్కడ మధ్యలోనే కదా మనం ఇన్స్టాల్ చేసింది ఇందాక SCBs.
Yes, sir.
This is
Yes, sir.
MX960. This is MX960 chassis. Okay. So this is where
Material.
you, yeah, God mute. This is switch control board. Once you install, right, you see, right, these pins, the copper pins. So this will be installed to line card. So this is MX480. Look at this. This is MX480. Okay. So yeah, this is MX960. So you can see, right, front end, you have SCBs and routing engine. So SCB means what? Switch control board. How many SCBs we have? 1 plus 1. Routing engine also 1 plus 1. Why we used to say 1 plus 1? One is active, one is redundancy. Okay. Yeah. These are main things. Now, other line cards. You see, right? Other we called what? Line cards. These line cards we call MPC and DPC. What do you mean? MPC and DPC. MPC means multiple port concentrator. DPC means dense port concentrator. So MPC means what? Multiple port concentrator. MPCs. So the DPC, these are the legacy line cards. No one is using right now. These are the old line cards. Now everyone is using MPC line cards. In MPC, we have types. MPC type 1, MPC type 2, type 3, type 4, up to 10, type 10. And they are manufacturing advanced level MPC line cards. So the MPC line cards are installed in this chassis. Look at this. What it will having? It will having a interfaces. So we discussed, right, in a hardware. In every routers, you have a two components. One is where you install your operating system. Another one is where you are connecting to another devices. These are the line cards. These line cards having interfaces. They are connecting to another router. Okay. So total how many slots it is having? 14 slots, right? Out of 14 slots, these two are what? SCB and routing engine. Remaining 1, 2, 3, 4, 5, 6, and 6. 6, 6, 12. These 12 slots where what you will install? MPC line cards. These MPC line cards will have a interfaces like this. Is it clear, everyone? See, if the customer want 1G interface, you can purchase a 1G interface line card. If the customer want 100G bandwidth, so you can purchase a line card where you have a 100G interfaces. 1, 2, 3, 4, 400G interfaces is there. You can connect it like this. Understand? So depends on the customer requirement, depends on the usage. You can purchase different customized line cards. Clear? Based on your requirement, you have a line cards. Is it clear, everyone? Hello.
Yes, sir.
Yeah. Now next one is SFPs, right? SFPs, small form factor pluggables. You have 1G SFP, 10G SFP, 100G SFP, and you have SR SFP for short range, ER SFP for extended range. That we have already covered in hardware training. Yes or no?
Yes.
Yeah.
Yes, sir.
Yeah. Now you have fan tray. What do you mean by fan tray? So the heat which is coming from the device will exhaust through fan tray. This is also a hardware component. Next is power supply. Look at this. MX480 is having how many power supply? 4. You must say 2 plus 2. It means 2 are active, 2 are standby. Okay, total how many power supplies it is having? 4 power supplies.
Okay.
But you may have to say 2 plus 2. Okay, yeah. Now next is craft interface panel. What does it mean? It means simple. This is it. It is a LED indicator of each and every line card. Look at this. If SCB goes down, right, it will red LED will turn on. In case if the line card 2 goes down, right, red LED on this slot, it will turn on. Okay. So craft interface panel, it is just a LED indicator. Is it clear? So these are the Juniper hardware components. So SCB, routing engine, you will install your operating system. line cards, SFPs. These are the line cards which are very important, MPC line cards. All the packets are hitting this line card interface only, right? Yes or no? All the packets, the data which is hitting on interfaces only, right? Because it is connecting from different routers. Where exactly the data is hitting interfaces? You have a connectivity, right? So this is a router, this is a router. You have a connectivity. So where exactly the data is hitting this interface? Yes or no? Hello?
Yes, sir.
Data is hitting on where interfaces only, right? Yeah. So the packets arrived on interfaces, and here MPC line cards can process it further. We'll learn now in Juniper how it will process. So everyone is clear about hardware components of Juniper? Hello? Everyone is
Yes, sir.
clear?
Yes, sir. Yes,
Yeah.
sir.
Yes,
Yeah.
sir.
Yeah. Now let's understand the packet flow. Look at this, everyone. Go on mute. Okay. So the beauty of Juniper is, listen carefully. Why I fall in love with Juniper, I'll tell you. It changed my life, the way of understanding of technology. Okay. So the Juniper was founded by the Indian. He was a IIT graduate, 1997. Okay. So check it. Okay. Very good vendor. So anyhow, let's coming to the very beautiful feature. Here you will install your Junos operating system in routing engine. Yes or no? You will install a Junos operating system in routing engine, and all the routing protocols, all the switching protocols, whatever it is, you will configuring in a routing engine. Okay, fantastic. Now, once you configure your routing protocols like static routing or default routing or dynamic routing, so it will build a routing table, right? Yes or no? You will have a routes and routing table. Yes or
Yes,
no?
sir.
Okay. So that routing table where you will see in routing engine only. Yes or no? You are configuring a routing protocols on routing engine, and the routing table built in routing engine only, right? Hello, hello.
Yes, sir.
Yes,
Yeah.
yes.
So in routing table, you see all the available paths. If I want to reach 8.8.8 or some IP address, so if you configure same there is a same destination. The same destination is having multiple routes in routing table. One is via OSPF, one is via static, like that. Okay. So what it will choose based on the lower administrative distance, it will choose the route. Yes or no? If you have a route if you have a route in routing protocol, and you have a multiple paths to reach one destination, multiple paths to reach one destination. Okay. So routing table contains all available paths. Generally, you want to travel from Hyderabad to Bangalore. Look at this maps. If you want to travel from Hyderabad to Bangalore, so what are the available paths you have here? Generally, you have multiple paths, right? Suppose, right? Look at this. You may have multiple paths. Yes or no? Two paths you have. Is it clear, everyone? Hello? You have two paths.
Yes, sir.
So all these available paths is showing in where routing table. Similarly, you have a 8.8.8 route. Okay. This 8.8.8 is learning via static route as well as OSPF. So this is what all the available paths. How many paths you have for one destination? How many availables whatever you configure, right? How many available paths we have? Everything, right? Everything will show in routing table. In Juniper, all the available paths will be there in routing table. And out of this table, right? It is static. This is static. So which one it will prefer? Static or OSPF? Which one it will prefer?
Static, sir, because AD is less.
Yeah,
Static.
ADCS said, yeah. So the best paths. So you have available paths, multiple paths. All the available paths will be there in routing table. But the best path, either static or OSPF, the best paths are available in forwarding table. Understand the difference between routing table and forwarding table, everyone? So
Yes, sir.
routing table contains all the available paths. Okay, a routing table contains all available paths. So, uh, hello, can you hear me, everyone?
Yes, sir.
Okay,
Yes, sir. Yes, sir.
okay. So, anyone is unmarried here? Anil Kumar, Aravind, anyone unmarried? Anyone bachelor here? Just I'm telling you.
Yes, sir.
Yeah.
Yes, sir.
Who is that? Rohit, Karthik.
Yeah, yes,
Okay.
sir.
సో రోహిత్ వెంటే యూనో పెళ్లి చూపుల్ని ఏమంటారు మనం? సో యా. సో you have seen multiple, either girl or boys, they will see multiple persons, right, for arranged marriage. And you will, so all the, see what, how many you see, right? You will, yeah, how many you see, that like how many people are available to marry, like either men or women, right? So that is called all the information. Now you will choose only one, right? You cannot choose two. Someone will slap if you choose to, right? So you have to choose only one person, the best person, right? So all the available information you have in your mind, okay, that is called routing table. You will choose only one person, the best partner. That is called what? Forwarding table. You understand now the difference between routing table and forwarding table? All the available paths to reach one destination, all the available paths to reach one destination is called routing table in Juniper. The best path, whatever the best path you're choosing, right? That is called forwarding table. If you check in Google Maps also, if you if you go to any location, you'll follow the Google Maps, right? So it may show you multiple paths, but best path it will show you. Okay, yeah, that is called routing table and forwarding table. I may given a wrong, I mean, example, but you may easily remember. That's why I gave this example. Is that okay, everyone? Hello. You're not offended, right? Everyone, hello. Can
No.
you hear me?
Okay, sir.
Okay, sir.
Yeah, yeah,
No, sir. Yeah.
yeah.
Yes, sir.
So everyone understand, right? What is forwarding table and routing table? Everyone, is it clear? Very important.
Yes,
Everyone,
sir.
okay. Now, fine, fantastic. So the beauty of Juniper is this routing table and forwarding table. Where you will see in routing engine, right? You will see in routing engine. In routing engine, you will install your operating system and you will configure all the routing protocols. After that, it build a routing table. Okay. This building a routing table is called what? Control plane. So what do you mean by control plane? The control plane dealing with routing protocols and it build a routing table. That is called control plane. And how the data is exiting my device, it is there in the forwarding table. It is called what? Forwarding plane. So the control plane is, it deals with routing protocols and all the available paths will be there in routing table. That is called control plane. Forwarding plane means which path is the best path, you're choosing it. That is called forwarding plane. Everyone understand? Control plane and forwarding plane and routing table and forwarding table.
Yes, sir.
Well,
Yes, sir.
yeah. So everything will
Yes,
be
sir.
in where? Everything will be in routing engine. Okay. Now the beauty of Juniper is, so one copy of forwarding table, one copy of this forwarding table, it is giving to all MPC line cards, all MPC line cards. So look at this here, where exactly the data is coming. Look at this R1, R2, R3, they are connecting each other. If the data is coming, going from R1 to R3, it is hitting on here. Yes or no? From R1, the data is hitting on G2/0 interface. Yes or no here? Hello?
Yes, sir.
Yeah.
Yes, sir.
So this is called what? Line card. This MPC line card, you can say line cards, you have MPC or DPCs. These line cards have a chipset internally. That is called what? Packet forward engine. Okay. So this line card, right? Here you see all the interfaces, backend. Backend they have connected with a chip. The chip is called ASIC. What is that? ASIC, application specific integrated circuit. Okay, a processor. So this chip is connecting with how many interfaces? 12 interfaces or 20 interfaces, like this. It means whatever the data is hitting on these interfaces, okay, this processor is handling it. This is called what? Packet forward engine. Yes or no? Packet is receiving on this interface and it is forwarding it. Who? The chip. This is called PFE. Packet forward engine. Everyone understand? Hello?
Yes, sir.
So what I mean to say is in MPC line cards, so this is a MPC line card. You can say like this. You see, right? This is the MPC line cards. You will install on the device. MPC line card motherboard. Let me tell you internally. Juniper. Yeah, you can see, right? This is a line card. This is having so many ports, right? If you see, right, back end lot of chips. Are you seeing the processors? Hello, people,
Yes, sir.
right?
Yes,
So,
sir. Yes.
so this,
Yes,
the,
sir.
so the here how many ports? One, 2, 3, 4, 5, 6, 7, 8. 8 plus 8, how many? 16. All these 16 ports, traffic can handle to some chips here. This chip is called what? ASIC, and this is called application specific integrated circuit. Make sense now? So internally in MPC line cards, what you have? PFEs. What we call PFEs. Look at this. This is called what? Packet forward engine, because you're connecting a cables on these interfaces. So the data is hitting on these interfaces. This data is handled by this chip at the back end. This is called what? Packet forward engine. Understand what do you mean by packet forward engine? It's a chip. Okay. So
Yes, sir.
where you will see the PFE, the packet forward engine, which line card you will see the PFE, in which line card you will see the
MPC.
MPC.
fantastic, fantastic, very good answer. So fantastic. Go on mute. So my students got a job in Juniper Networks with high package. Even in Juniper Networks company, they are not giving this training. Still, they are referring my training only. KT. So this is called PFE. What is that? Packet forward engine. So these PFEs are located in where? MPC or DPCs, line cards. Okay. Now the beauty of Juniper is this one of the forwarding table, it is there in routing engine. It will copy this forwarding table and giving to PFE. It means the forwarding table is located in routing engine. So it will copy this forwarding table and giving to your what? PFE. You understand what I'm saying? The forwarding table, the how to reach a destination. The forwarding table, right? It is going to all the line cards PFEs. How many line cards we are using here? One, two, three, four only. Remaining all are empty line cards. Only four line cards we are using it, right? All the four line cards, the routing engine will send a forwarding table. You understand? Everyone. Ardhamainda?
Yes, sir.
So
Yes,
Yes,
sir.
sir.
this forwarding table, yeah, go on mute. This forwarding table located in routing engine. Go on mute. Yeah. This forwarding table located in routing engine. So what routing engine is doing? One copy of forwarding table it is sending to all line cards PFE, packet forward engine. So now you have it. Suppose look at this. Okay. Now look at this topology. R1, R2, R3. These are the 960 devices. They are connecting each other, and 1.1.1 is the R1 IP, 2.2.2 is the R2 IP, 3.3.3 is the R3 IP. Okay. Now look at this. So R2 routing engine, R2 forwarding table is what? R2 is saying that to exit 3.3.3. If you want to then if you want to reach 3.3.3, through G1 slash 0. So this is a routing table. That's how route is learned via static or whatever it is, via static. And 2.2.2 is a loopback 0 interface. Understand everyone? Hello? So it is there in where? This forwarding
Yes,
table.
sir.
Yeah, this forwarding table is in where? In routing engine. This entire forwarding table, it is giving to packet forward engine. It means the same information you see, right? The same information here. The same information, whatever you see in here, it is copying and sending to here, one PFE, one copy of forwarding table. Understand? Hello? Okay, this information is there in where routing engine. Whatever you see, right, this information, the forwarding table, it is in where routing engine. Okay, this one copy of forwarding table, it is giving where, it is giving to here, PFE. Clear? The PFE is located here. See, I draw it. So, see, this is a PFE. Okay, it means this entire forwarding table is located in routing engine. One copy it is giving to PFE. Now PFE have the details. Look at this now. So look at this. I am trying to initiate a ping from R1. So what is my destination IP if I initiate a ping from R1 to 2.2.2? 2.2.2, let's initiate for 3.3.3 first. Okay, where is that? I am initiate a ping 3.3.3. So what will be the destination IP? It will be 3.3.3. Yes or no? Whoever you are pinging, that will be the destination IP. Yes or no? Hello,
Yes, sir.
right?
Yes, sir.
Yeah. Now, once you initiate a ping, the packet will go to where it will travel, 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 and it is arrived on R2 G2/0 interface. Yes or no? It is arrived on G2/0 interface, and now it checks the destination IP. What is the destination IP? 3.3.3. Since this interface is part of packet forward engine, this packet forward engine is having a forwarding table. So it will check in forwarding table. So the route lookup, the destination IP route lookup is happening where? Within the PFE. It means within the packet forward engine only. It means here only it is happening. So do I have a route in my our forwarding table? Yes. 3.3.3. To reach 3.3.3, I need to exit through G1/0. I have this information. Okay. To reach 3.3.3, to reach 3.3.3, I have to exit through G1/0. So here it is a PFE. So PFE is having this forwarding table. Once the packet is arrived on this interface, it will do a route lookup in forwarding table, PFE forwarding table, and it finds that G1/0 is my exit interface to reach 3.3.3. So now the data will hit, the data will go to SCB and SCB to another SCB, and it is going to here. Now, whatever the data you are going to 3.3.3, is it going to routing engine or through SCB itself it is going to R3? One line card to another line card. It is going to R3. You understand my question? My question is it hitting to routing engine or it is going to line cards and one
Line
hello?
card, sir.
Line card.
Line
Line
cards,
card,
right?
sir.
So it is not disturbing
Mm.
routing engine. So our main processor is located in routing engine. Our main CPU is located in routing engine. So since it is not disturbing routing engine, there is no burden on routing engine. In case if this routing engine fails, there is no impact on this traffic. This traffic is called what? Transit traffic. Transit traffic means the data which is destined to another device through your device is called what? Transit traffic. See, I want to reach from R1 to R3. R2 is the transit device, middle device. So for all the transit traffic, it is not impacting. Yes or no? Hello? Hello?
Yes, sir. Yes, sir.
Everyone understand what I'm saying? This is transit traffic. The data which is destined to another router is called what? Transit traffic. It is not going to routing engine. It is not going to our original CPU. So there is no burden on CPU. That is the beauty of Juniper. In case if routing engine fails or anything happens, the transit traffic will not impact it. But Cisco, it is not like that. Everything is runs I mean software based. If software corrupt, everything will be collapsed. So Juniper will process the data based on the hardware. That's why it is very, very, very demanded device, demanded vendor. Like on a hardware base, it will send the data. So that's why the speed of data is very good in Juniper vendor. Okay, okay. Now if you want to ping 2.2.2, so 3.3.3, that is called transit traffic. Everyone understand, right? Transit traffic. Now, if you want to ping 2.2.2 and the destination IP address is 2.2.2, so this packet arrived on where? This device. And now look at this. It will check the destination IP 2.2.2 in forwarding table and finds that it is a loopback IP. So it's a loopback interface. So the data loopback interface is configured in your routing engine only, right? Interface loopback 0. So
Yes.
the data will go from this PFE to this SCP and SCP to routing engine. It means the traffic which is destined to your routing engine and your routing engine CPU will respond back is called what? Which traffic is it? It is called exception traffic. Understand? The traffic which is going to through SCP to SCP to other, this is called transit traffic.
Transit.
This is transit and this is exception traffic. E.
Like,
Everyone understand?
can you explain again, like transit and execute,
So
one more time, please?
transit means you are in Hyderabad. You're traveling
Mm-hmm.
to Bangalore. Okay.
Okay. Yeah.
And now in between you there is a stages called Jadcherla and Karnool and Anantapur, right?
Yeah. Yeah.
Karnool, Anantapur. Now your source is Hyderabad, destination is Bangalore. Between
Mm-hmm.
these guys are transit, right? మధ్యలో వచ్చిన device, I
Yes.
mean, so that is what it means. It's a transit traffic. Transit means the traffic which is not destined to you. So I'm trying to ping from R1 to R3. When I'm trying to ping from R1 to R3, R3 is my 3.3.3 is my destination IP, right?
Mm-hmm.
So the
Yes.
the packet is arrived on PFE here. So PFE is having one forwarding table. So to reach 3.3.3, you need to exit through G1/0. It means another line card. So the data can go to SCBs, SCBs to another. Go on mute. Please go on mute. Yeah. So 3.3.3 is my destination IP. So the destination IP, how
Mm-hmm.
exactly you need to exit? You have to exit through G1/0, which is on another line card. Okay. So the data can go to your PFE, PFE to the SCB, SCBC to the another line card. Okay. It is leaving here
Okay.
without
Yeah.
involving your routing engine. Is it touching your routing engine? Is it going your routing engine? No. Is it going your routing engine? Hello, brother, asking
No.
you only.
Yeah, no,
Yeah. Yeah.
no.
No.
Yes.
So
No.
this is called what? Transit traffic without disturbing you. So if you guys are asking me any question right after the class, I'm simply saying contact my team, right? So
Yeah. Yeah.
not to me. That is called transit. If anything to me, right? That is called you guys are asking when is the next batch. That can be provided by my team, not me. So that's what it is.
Yes.
If it is if the traffic is going to your routing engine, that is called exception traffic. If it is other, that is called transit traffic. Go on mute, brother. Very bad noise is coming.
Okay.
Yeah.
Not from me.
Oh, someone, please go on mute. Whoever it is, please go on mute. Who is that? Yeah, thank you. So the thing is, what I'm trying to tell you is, you have to understand one thing. SCB. SCB is a switch control board. It acts as a switch. Switch means this is a switch. Okay. So internally, it has a switch like this. Internally, threads, copper threads are there. All go on mute, man. Come on, guys. Please help me. Who is that? దుర్గా ప్రసాద్ గారు, దయచేసి మీరు మ్యూట్లోకి
నేను
వెళ్తారా?
క్లోజ్లో ఉన్నాను. నా దగ్గర నుంచి ఏ నాయిస్ లేదు.
అవునా? మీదే అన్మ్యూట్ లో ఉంది. మిగతా వాళ్ళంతా
నేనే
యా.
నాది జీరో నాయిస్. క్లోజ్ రూమ్ లో ఉన్నా.
మీది చిన్న చిన్న శబ్దాలు వస్తున్నాయి. జస్ట్ గో ఆన్ మ్యూట్ ప్లీజ్.
అయ్యో.
థ్యాంక్ యూ. ఓకే. సో వాట్ ఐమ్ ట్రైంగ్ టు టెల్ యూ హియర్ ఈస్ switch control board SCB. Internally, it has a circuit. It is called a switch. Okay. So this switch, right, is connecting to all the line cards. Look at this. How many line cards we have? It's a 24 port switch generally. Internally, it has a 24 port switch. This switch control board is internally connecting to all the line cards like this. Okay, called switch fabric like this. Look at this. This is SCB, switch control board. So internally you have a DPC or a MPC, right? This DPC or MPC line cards, you have a PFEs. All are connecting to SCBs like this internally. It means if you see here, if you see when you install a line card here, it is connected here, this motherboard. So these pins are internally connecting to SCBs here. You understand now? Whatever you install SCB line card, MPC or DPC, it is connecting to SCBs internally like this, like this, like this. All line cards are connecting to SCBs internally. Look at this motherboard at the back end. See the motherboard here, the back end, right? So once you install it, right, it will connect it to these pins back end. These are connected to all SCBs like this. Okay. So if you see here, right, look at this now. So this is SCB. This line card is connecting to this SCB like this. All these line cards are connecting to SCBs. So this line card also. Okay. So back end. So back end it is connecting like this. This is front end. That's why if any data arrives, right? That's why if any data arrives on these interfaces, it is going to SCBs, SCBs to MPCs. It is exiting. If it is a transit traffic, okay. Even this routing engine is also connecting to your SCB internally. Okay, it is connecting like this. This routing engines. If the traffic is destined, if the traffic is destined to your routing engine, it is going to your routing engine. So whatever it is, the traffic is sitting on interfaces. In the interface, you have a forwarding table. This is called PFE like this. In the forwarding table, if it is a transit traffic, how you will come to know transit traffic? Suppose you want to reach 3.3.3, the 3.3.3 is exiting through another line card interface. It is not going to routing engine. It is not your data. It is someone data. So it is exiting through G1 1/0 and hitting to this device. This is called what? Transit traffic. 2.2.2 is a loopback and it is to you. So if you want to ping 2.2.2, the data is going to where? The data is going to a routing engine. Okay, that is called what? Exception traffic. Now you understand everyone? Hello? Clearly about
Yes, sir. Yes, sir.
how exactly internally connected. So this is how. So internally it has a 24 port switch. That switch is not a switch. It's a motherboard. Motherboard you may see a copper threads, right? You might see a copper threads like this. Look at this. The lines, white lines and copper threads. Okay. So inside that you have a 24 port switch. Okay. All the line cards backside you see they are connecting to a switch control board. Backend. Once you install all line cards at the backend motherboard, they're connecting like this. Okay, like this. Okay, yeah. So this is all about control plane and data plane. So what do you mean by control plane? Control plane means it deals with the routing protocol and it build a routing table. Where it will happen? It will happen in routing engine. Data plane means the best routes will be there in forwarding table and one copy of forwarding table it will go to where? Which engine? Packet forward engine. Where the PF is located? Can anyone tell me where you will see the packet forward engines?
Multi-port
M-
connectors, MPCs.
MS
MPCs.
MPCs.
Yeah. Multiple ports concentrator. Fantastic guys. Good. Okay. Yeah. So now this is the backend architecture. Like, if it is MPC, DPC, right? Internally you have a PFEs. All the PFEs are connecting to SCBs. SCB0, SCB1 like that. Okay. Yeah. Now this is a line card. This is a MPC line card. Inside the MPC line card, you will install sub line card. So this is the MPC line card, right? Look at this here. In this line card, you may have a slots, sub slots. In the sub slots, you will install these MIC cards, modular interface cards. Like this, some customer asking, hey, I need a copper for RJ45 interfaces. I need satellite interface. I need serial interfaces, SFP interfaces. So based on the customer requirement and the bandwidth, you can install that MIC cards inside the MPC card. Okay. So this is a switch control board. Look at this. The backside you have a pins, right? Once you install it, it is connected with motherboard. Okay. This is module interface cards. In Cisco, we call IOMs, input output modules. Okay. Yeah. So this is a complete Juniper architecture. You know, right? Control plane you will see in routing engine. Data plane you will see in packet forward engine. How the packets are hitting? The packets are hitting on interfaces, PFE, called data plane. So I said, right, you have a forwarding table. One copy of forwarding table it is giving to PFE, right? Look at this forwarding table. The best paths, the forwarding table will be having a best paths. Okay. Now in routing engine we have a components, guys. Very important. Routing engine components. What are the routing engine components? Very important. These are the software daemons. Daemons means not a ghost. Daemons means processor, software processor, not a hardware processor, software processor. So the Juniper kernel, everything is built with Linux operating system. So in Linux, we have a daemons. Same here also. Suppose MGD, management daemon. What do you mean by management daemon? If you want to log in the devices through SSH, that SSH process is a management process. That entire process is taken care by MGD. Understand? MGD means management daemon. If you want to log in the device through SSH or console, that entire task is handled by this separate processor. So suppose in your Juniper router, you are not able to log in the MGD. I mean, you are not able to log in the device through SSH. There is an issue with the MGD process. You need to restart or kill this process. Okay, sometimes. Okay, so yeah, like that. And next one is RPD, routing protocol daemon. You guys are configuring routing protocols, right? Like a static route, default route, OSPF or BGP. Whatever the routing protocols you are configuring, that entire process is taken care by RPD, routing protocol daemon. So if your routing protocol, you even if you configuring a routing protocol and it is not working fine, RPD is a problem. So the problem is if routing protocol daemon is not working, okay, so other daemons are working, right? So each task you have a separate process. That is the beauty of Juniper. For login the device through SSH, we have a separate process. To handle the routing protocols, we have a separate process. Next is DCD, device control daemon. It means you're going to assign a IP addresses on interfaces, right? The interface stuff. If you're going to assign the IP addresses on interfaces, ACLs on interfaces, whatever it is, if you're trying to do anything with interface, that process is taken care by DCD. Clear? See, for each and every task, you have a separate process. And chassis D is separate process. It means if anything happened to your device, in Juniper device, it will create a alarms. Suppose power supply failure, routing engine failure, SCP failure, interface down. If any hardware issues, right? Chassis daemon will monitor it and it will show you in the form of alarms. Okay. So the alarms are if chassis daemon will monitoring entire your device. And you have a PFED. What is that? Packet forward engine daemon. What it will do? I told you, right? It will copy of one forwarding table to PFE. So the copying of forwarding table from routing engine to packet forward engine. Who is doing that copy of forwarding table? The PFED. The PFED daemon, it will copy a forwarding table from routing engine and send to PFE. So these many are RPD, DCD, MGD, chassis FED, and if you configure SNMP, SNMPD, for each and every protocol, I mean protocols and tasks, we have a separate daemons. In case if anything happened to the management daemon, other tasks are working fine, it won't impact. Cisco is not like that. Everything is with one single software process. If software is corrupted, everything will impact it. But in Juniper, you see, right? You have a separate processes for separate tasks, right? Understand everyone? This is called routing engine components. Everyone is it clear about daemons processes? Hello?
Yes.
Yeah. Now PFE components. PFE is located in MPC and DPC, right? These are the MPCs. I told you types of MPCs. MPC type 1, MPC type 2, type 3, type 4, like that. Internally, they're using a chips, ASICs. Okay. First generation of MPC line card, it is a 8, it supports up to 80 gigabits per second bandwidth. So here you have a 4 chips. It's a first generation line card. Exam. See, once the data is hitting, right? So that will be check a destination IP. The input and output operations are done by this IX chip, and then it will store the information memory chip. So then it will do a lookup. LU means lookup chip. COS means QX means COS operations. So each and every task internally, right, to perform that you have a 4 chipsets. Simple, just remember PFE components. We have a internally chipsets. It is not required for you, but I'm just telling you. But later they manufacture generation 1.5 line card with 130 gigabits per second. This is here you see 3 chips. So these two they combine and call as a exam chip. And then they go to generation 2. It supports 260 Gbps per second, and they advanced these 3 chips. Now the final chip is generation 3. This chip is a Eagle chipset, and you will see this chipset from MPC 5E, MPC 5. We have a types of MPC line cards, right? Type 1, type 2, type 3. Each line card they're increasing the you know bandwidth of the traffic. So generation 3 line cards can support up to 480 gigabits per second. So this entire data handled by one single chip. They combine all things and given as a one single chip is called Eagle chipset. Okay. Inside the packet forward engine, inside the MPC card, whatever the chips you're using, those we call a PFE components. Okay. That's it. And transit traffic, the traffic which is destined to another is called transit traffic. The traffic which is destined to your router is called exception traffic. Is it clear, everyone? So yeah, that's all for today. Everyone understand PFE components? Just chips. Remember, PFE components means internally chips, ASICs. Routing engine components are daemons. And this is a transit traffic, exception traffic. I explained very beautifully with this diagram. This is all about Juniper Day-1 class. All about hardware, internal architecture, and daemons components. Everyone understand today class? Anyone having any questions? Anyone having any questions?
No.
So how is the Juniper class? Interesting?
Good. Yeah, it's good.
Yes, sir.
Interesting, sir.
Nice, sir.
So Juniper product is very good. Commands also very good. The thing is, the commands you commands will be little you feel difficult, but once you started practicing, right, it is a dead easy. Juniper commands are dead easy than Cisco. But the first time, if you see, right, first time everything will be difficult. You feel difficult. Once you started practicing, it is easy. Okay. Yeah. So this is all about Juniper hardware, guys. So Junos OS fundamentals, we have successfully completed the fundamentals. So tomorrow we will start doing login the device and start practicing CLI. So my team will give you Junos image now. Everyone, please add the Junos image in your GNS3 tool. Okay. So it is having a 5 GB of operating system. The Junos image is a 5 GB of operating system. So I cannot send the file to you WhatsApp, right? So that's why I compressed it, and it is have a 270 MB. You need to extract through 7-zip file. My team will help you. So do not click on the Junos operating system file. People are clicking on it and trying to open in desktop. How you will open your operating system on desktop? Cannot. Okay. So yeah. So my team will send you all the installation process. Please follow it and install it. Thank you. That's all for today.